considers Hershey's to be a normal good, we would want to draw the tangency somewhere on this portion of the new budget constraint. If we wanted to draw it for an individual that considers Hershey's to be an inferior good, we'd want to draw it somewhere to the left of B. So let me just draw you a random indifference curve that makes Hershey's an inferior good. I2. What are you doing? Thank you. So this is now my point C right here. Point C is my highest indifference curve, right, that I can be on and still be tangent to my new budget constraint, and C lies to the left of B. Right? That means my income shifted up, and I decreased my consumption of Hershey's. So the income effect is B to C. So B to C, this move over here, that's my income effect. So my income effect here is negative, right? Income goes up, I reduce my consumption, works in the opposite direction of the substitution effect. So an individual, for a given the willingness to substitute here, that considers Hershey's to be an inferior good, they will see a much smaller price responsiveness than an individual that considers Hershey's to be a normal good, right? If Hershey's were a normal good and the tangency were out here, you'd see a hop from A to B to and C out here, and the total effect would be a drastic increase in Hershey's consumption. Because for this individual, Hershey's are an inferior good, it actually works in the opposite direction of the substitution effect, and the overall effect from A to C is this tiny little bit right here, right? So whether a good is normal or inferior to you has something to do with how price responsive your displayed demand is, which is pretty insightful. Now let's talk about unicorns for a second. Giffen goods. So I talked about this a little bit. There are these crazy goods out there that some people have argued they've spotted in the wild. So they say they saw a unicorn, all they saw is a rhino, and they just don't know the difference. But let's say these unicorns actually exist. Can we draw behavior consistent with somebody who consumes less of a good as the price of that good drops? And the answer is, of course we can. We can also draw pictures of unicorns. So let's do that, just for some practice. Hershey. Reese's. Thank you, Max. You've only done this a million times. Let's draw this for a so-called Giffen good. Same budget constraint we started with here, so 10.5. Let's again do a price drop to 10.10 here. Same scenario as before. But now I want to draw a scenario where that individual's overall consumption of Hershey's goes down as prices of Hershey's decrease. Sounds crazy, right? Why would you consume less of something when the price of something goes down? Agreed. So the way to do this, and this is hard, takes years of practice, and I'm definitely going to screw it up right now. Let's try this. Okay, what you want is you want a really flat indifference curve here. Nope. Have a granola bar break. This might take a while. Oh, no, got it. All right. Really, really flat indifference curve. And then one that sort of comes down like this. That looks pretty good. This is I1. This is the old budget constraint, and this here is the new budget constraint, right? Again, let income be 10, price of Reese's be 1, price of Hershey's initially be 2, and then the price of Hershey's falls to $1. So I want to draw this income and substitution effect, but in a way that the income effect is bigger and in the opposite direction of the substitution effect, so I actually end up somewhere up here on this budget constraint here to the left of my original consumption bundle. So this here is point A. Now, if I wanted to figure out what my substitution effect is, we're so good at this now, it's almost boring, but take your new budget constraint, shift it in parallel, right? Tangency somewhere right here. Or take your original budget constraint, rotate it around until it's parallel to the new one, right here, same spot. So if we draw our fictitious budget constraint, we would get something like this. This here is point B. Right, so our substitution effect goes from like 2.8 to 4.2 or something like this. So that's my substitution effect. Hershey's became cheaper, I consume more of them. Yay. Here comes the income effect, all right? The income effect now doesn't just have to get me to the left of B like an inferior good, but it has to get me to so far to the left of B that it actually goes beyond A. Because after a price drop, I want to consume fewer Hershey's than I did before the price drop. So you need to get a tangency not only to the left of B, but you need to get somewhere up here. So for the good to be Giffen, the tangency has to be on the new budget constraint somewhere to the left of A. So let me draw you one of those. I'm going to draw it in, if I had pink, I would draw it in pink because that's what unicorns are, but I don't have pink on this thing. Okay. So it could look something like this, I2, and this here is point C. That's the ultimate consumption bundle. So what you would observe in the wild is you would see a price drop of Hershey's, and you would see that individual consume fewer Hershey's, holding income and price of Reese's constant, which is an odd thing, and we don't really see that. Right? So the overall income effect now is my move from B to C. So let's look at that for a second. Right? B to C, the income effect is negative. Right? And the point here is it's not only negative, but its magnitude is so big, it drowns out the substitution effect and goes beyond the substitution effect in the sense that your overall consumption levels of Hershey's go down. So points to the left of A are Giffen. Points to the left of B are inferior. What does that tell us about a Giffen good? Yeah, super inferior is one word, but a Giffen good is just an inferior good where the income effect is so strong that it actually swamps the substitution effect. But a Giffen good is a really, really inferior good. All right? So that's that. This is hard, trust me. If it makes a little bit of sense right now when you go home and you try and do this yourself, you will drive yourself slightly crazy. So I would ask you to practice this as much as possible, and when you feel like you're going a little bit crazy, take a break and then get back to it after an hour. But this is not straightforward, and drawing these, especially in exam settings, is not fun. All right. So why do we care about this, Max? So I've asked myself that question, and I'm on a mission to make you care about income and substitution effects, right? So I want to take a brief detour here before we move on to the firm, which is really what's next, and talk about labor supply, right? So the class is sort of split. We spend a couple of weeks on the individual and then a couple of weeks on the firm, and then we put them all together, and then we show you why the competitive market that doesn't really exist in the real world is just a benchmark, and then we kick the competitive market in the knee and see what happens to human welfare, right? We're done. But I want to sort of build a little bridge between consumers and firms, because this model of consumption that we've just built translates beautifully into how individuals decide on how many hours they should work in a given day, and it actually has huge ramifications on what tax policy could be. So I'm going to take an hour of your time, a little bit today, a little bit next time, and explain to you why this is so important and comes up in elections all the time. Next year's election year, so it's going to be an interesting year. All right, so let's take our model and give it a few different labels, but essentially use the exact same model we have to discuss how people choose to work or leisure. All right, so I'm going to come up with a really simple model of the world, like the Reese's and Hershey's thing. You can complicate this as much as you want, and it makes things interesting, but not that much more interesting. So I'm going to assume that you can do two things with your time. You can work, or you cannot work. If you work, you get an hourly wage. If you don't work, you don't. Okay? We could have a long discussion about how not getting a wage doesn't mean you're not working, right? If you are a parent at home choosing not to work, there's an opportunity cost of you not working, and you're not getting an explicit wage, but of course it's work, right? For those of you who have children, nieces, or nephews, you know it's work, right? But I'm going to keep the world simple here for a second and just look at, do you participate in a job market where you receive an actual hourly wage, right? This doesn't mean that not making a wage is not valuable time spent. It just means you're doing something else. This could be parenting. This could be playing Xbox on your couch. This could be volunteering somewhere for no money, all of which are desirable things, but you're choosing to not spend time at a job that gets you an hourly wage. So work or do other things. When you work, you get paid. When you don't work, you don't get paid. So there'll be some work in the real world that I'm going to classify here as not working, but working in this model, you get paid. I'm going to assume, and if anybody picks on this, I'm going to send you straight back to the physics department. There are 24 hours in a day. I know it's not exactly 24 hours, but let's not worry about that. And I'm going to confront you with the problem that many of you decide, assuming you can choose how many hours you work in any given day. Let's assume away 8-hour shifts and so on. You have to decide how many hours to work and how many hours not to work. So do you consume what I'm going to call leisure, which is time spent not working, or do you go and consume income, which is what you get from working? So let's write out some very, very simple formulas. This is really easy, okay? I'm going to assume that you have a utility function that's defined over two goods. Previously, our utility function was defined as Reese's and Hershey's, right? Now, I'm going to say that your utility function is not defined over Reese's, which is a good, and Hershey's, which is a good, but it's defined over income, right? How much money you have that you can spend on then Reese's and Hershey's if you want to. So it's defined over income and leisure, right? We get utility, happiness, out of time off and income. World's more complicated than that, but let's keep it simple. The amount of income you get per day, I'm going to call Y, right? Because that's what economists call it. The hours of leisure a day, I'm going to call N. Because L is a confusing letter, and people always think it's labor, not leisure, so we're going to call it N for not working, okay? So hours you spend in a day not working is N, hours worked is H. So the complication that comes in here, of course, that in a given day, how many hours you work and how many hours you leisure have to add up to 24 hours, right? You can only do one or the other. For each hour you work, you get W dollars. So your budget constraint here is a really simple one. You have 24 hours in a day minus the number of hours that you leisure, right? So 24 minus N gets you that number of hours worked. So 24 minus N is just H. So income is wage per hour times the number of hours worked. So if you work 10 hours, you get $10 an hour, you make $100, and you consume 14 hours of leisure. So the other way to write this is Y equals W times H. It's the same thing. Now, what does this look like in a graph? So I've just shown you something. You have two goods. You have income. You need your Y-axis. Income is also called Y. So I'm making it really easy for you, right? Income is called Y, and it goes on the Y-axis. On the X-axis, I have leisure, right? So the more units I get on the X-axis, the more units of leisure I get. It's something I like. It's a good. On the Y-axis, the more units in dollars of income I get. It's also a good. It's not that different from Reese's, right? More Reese's, more better. More Hershey's, more better. So instead of having Reese's and Hershey's, I now have income and leisure. The one difference you have between this graph and the one we drew previously, Hershey's you could consume an infinite amount of, right? Well, not really, but let's assume you can. I tried. But leisure, you run into a constraint here that after 24 hours of leisure, there's just no more time, right? So it's your X-axis here ends at 24 hours. So as I go from left to right, I increase my hours of leisure, but as I go from 24 to the left, what am I increasing? Hours of work, right? So at the origin here, I'm working 24 hours. I'm consuming 0 hours of leisure. At 16 here, I'm consuming 16 hours of leisure, and I'm working 8 hours per day. So that's the sort of average number of hours worked, roughly 8 hours per day, and the rest of the time you do other stuff. So this here, the X-axis just presents left to right leisure, right to left hours worked. So what I'm going to do is I'm going to draw your budget constraint. I'm going to rule out that you have a stash of money sitting somewhere, right? So if you have some wealth, trust fund, or you saved money, or you had your own startup and you're here because you really want to be here, you don't need to make money in the future anymore, but you just really want to learn economics, welcome. Everybody's welcome. But the point here is I'm going to rule out wealth. I'm going to assume everybody has $0, and the only way to get money is to work an hourly job. Doesn't change the prediction, just makes drawing a little bit harder. So if I work in a job where my wage is $10 an hour, well, if I work 0 hours, I have $0 of income. If I work 10 hours, how many dollars do I get? 140. If I work, 10 hours, that's 14 hours of leisure consumed, right? I get $140, that's roughly here. So for each additional hour that I work, I get 10 more dollars. So as I move from the right side here, 0 hours worked. First, did I screw up? Oh, yeah, thank you. All right, let's try this again. I jumped ahead. 0 hours, $0. We're good, right? 1 hour, how many dollars do you get? 2 hours, 3 hours, 24 hours, 240, right? So with each additional hour of work, you get 10 more dollars. That's just a straight line that goes from the origin on the right-hand side here exactly up to 240. So if you worked all day, you worked a 24-hour day, you would walk home with $240. If you work 0 hours, you walk home with $0. If you work 8 hours, 16 hours of leisure, you get $80. Thank you for catching that mistake earlier. All right? This here is my budget constraint. Does this look different from the budget constraints we've drawn so far? No, it even has the same color, right? It's a budget constraint. This is if you spend all your time working, how much income you can get. This is if you spend all your time leisuring, how many hours of leisure you can get, right? It's a regular budget constraint. So let me show you Max's indifference curve over labor and leisure. So Max's indifference curve over labor and leisure looks something like this. I1. So Max is going to get on the highest indifference curve between income and leisure, right? Those are the two goods in this model. The highest indifference curve is 1, where his indifference curve is tangent somewhere at, the way I drew it here, roughly 13 hours of leisure, or 11 hours worked, right? So Max works roughly 11 hours and gets in exchange a glorious $110. That's right, okay? 11 hours of age for $110. So what I've got now is I've got a model where Max considers income and leisure as imperfect substitutes. These are my preferences. I'm willing to give up a little bit of leisure time for a little bit more money and vice versa. I'm facing a budget constraint where I get $10 an hour, and I'm getting myself on the highest indifference curve I can that still shares a point with the budget constraint. This is the exact same graph we drew for Reese's and Hershey's. All I've done is I've relabeled the axes. So what I'm going to do, I'm going to do this today. Let me see my next picture. Let me give you a flavor. 2 minutes, all right? I've got 2 more minutes. Let me give you a flavor here of what we can do with this amazing model. So Max here works 11 hours. What if the economics professor is badly dressed, the badly dressed economics professor union comes in and says, professors shouldn't work 11 hours a day, they should work 8 hours a day. So they convince the university that after Max working 8 hours, he doesn't get any income anymore. So that means I get $10 per hour for the first 8 hours and 0 thereafter, right? So 8-hour work week. I'll do this more formally next time. But what does this do to my budget constraint? Well, what this does to my budget constraint, it changes it. It changes it at exactly this point right here. At this point, I work 8 hours, right? I have 16 hours of leisure. If I work the 9th hour, I no longer get those additional $10 to get me to 90, but I get $0. So my budget constraint looks like this, where I get 0 additional dollars for any hours worked after 8. So I get this kinked budget constraint, right? That's different from my original one. Can I still work my original number of hours and get the original amount of income? No, right? There's no point on this indifference curve that still gets me here. So what's going to happen to poor, overworked Max here is he finally gets to work 8 hours. This is I2. So victory. Max finally works 8 hours. Is Max happier? Max is pissed off, right, in this particular scenario. Why is he pissed off? Because he's now working 8 hours, but he's on a lower indifference curve than he was before. He really liked his income and wanted to work a little bit more to get this additional income. So I'm going to work this out in more detail next time, but this shows you 8-hour work weeks, overtime, and so on, what this does to individuals. For some individuals, it won't affect their welfare. For others, it will. So I will see you on Thursday.